Welcome to our first actual science class in the virtual 2021 school year. Today we're going to start off by learning a little bit about the scientific method and the units that we use to measure things. At one time in history, everybody had different units of measurement. So if you went from one town to another town, they would be using different units of measurement. And especially if you went from one country to another, they would use different units of measurement. And usually people sort of used what was around, and we still have some of that today, left over. I think people have things like, they call it a cup. Well, whatever the size of the cup was in your town, it was a cup. And, or a foot, it was like, okay, well, it's as long as a foot, but like whose foot? So people really didn't know what they were talking about. So people decided that they needed to agree upon standardized units. And this is when everybody agrees what the same units of measurement are going to be. Okay? And people did this so that they could communicate with one another and they wouldn't get confused. Okay? If, for example, if we were talking about a foot and somebody said, back in those times, send me some boards. And you're like, okay, well, I'll send you 6 feet, and you use my foot. Well, it's pretty big. And compared to somebody else's foot. In the United States, we have 2 systems of measurement that we use. We use the standard system, which the real name for the standard system is the imperial system. And the empire that we got it from was the British Empire when we were a colony. The metric system is the system used by the scientific community and also really the rest of the world. And when I say it's used by the rest of the world, I have this map showing the places where it's used. And you can see that all the countries in green are where the metric system is used. The only exceptions are Liberia and Myanmar. The United States is kind of in this light green because we use both. We have the metric system, and then we have the leftover imperial system from when we were a British colony. Quite often the metric system is also called the system international. And really the metric system came into existence with Napoleon and his marshals. As Napoleon had conquered most of Europe, in his new empire, he wanted a standard system of measurements so that the areas of his new empire would be able to communicate with each other. Napoleon and his marshals came up with the metric system, and a lot of the metric system is based on water. For example, 1 gram of water equals 1 milliliter, or vice versa, 1 milliliter equals 1 gram of water. The thermometer they took and made the 0 where water freezes, and the 100 where water boils. Whereas the old imperial system was based on things that you could find around like a cup or a foot. So, they had these things. Also, the metric system is based on units of 10. So Napoleon and his marshals thought that it would be a good idea if the new measuring system was based on units like how we count. So it would have tens, hundreds, thousands, and then going the other way on the other side of the decimal, it would have tenths, hundreds, thousands. Okay? Now, our old imperial system is based on fractions, and that's one of the reasons why people don't like using it. If this piece of paper represented a whole gallon of milk or a whole foot, well, the reason why it's based on fractions is because it was easy to cut things in half. So if this was a gallon of milk, we would end up with having half a gallon of milk if we cut it in half. And then we would have quarts or quarters if we cut it in half again. And if we cut it in half again, we would have eighths. Okay. And if you think about the way an inch looks on a ruler, you have a half of an inch, a quarter of an inch. The marks go down to an eighth of an inch. And then if you cut an eighth in half again, okay, it goes down to a 16th. So by cutting things in half, which is pretty easy to do, like I cut each of these sections of the paper in half, you ended up with 16ths. But when Napoleon and his marshals were making the metric system, they said, we don't like working with fractions any more than the average 8th grader at LCMS likes working with fractions. So we're going to base it on units of 10 so that it's easy to count that way. Just like we have prefixes that we put before the numbers, like we say it's a tenth or a thousandth or a hundredth, or it's in the tens, the hundreds, the thousands, the metric system works just by putting prefixes like that in front of the numbers. The base unit of measure for mass is the gram, for length is the meter, and for liquid volume, it's the liter. And then you put these prefixes like centimeter, milliliter, or kilogram in front of these base units. Centi is a hundredth. Milli is a thousandth. Kilo is 1,000. So this would be the thousands, this would be a thousandth, and the centi would be 100. And you kind of have heard these prefixes before, like how many years in a century? 100. Centi is 100th. In a millennium, there's 1,000 years. A milli, like millennium, is a 1,000th. By using those prefixes, you can have these units, the meter, the liter, and the gram, and work with very large measurements like kilometers, which is, people just say a kilometer. That's 1,000 meters. Or you can work with really small numbers depending on what you're doing. But you still use those base units, the grams, the liter, and the meter. The prefix gives us the same value in a different measurement size, like kilometers are small or large, and then millimeters are small. Now, in order to be able to move the decimal around and go from one prefix to another, we use what I call the swoop method. And we're going to swoop because we're going to swoop from one place to another. The way I remember this is this little acronym: King Henry died usually drinking chocolate milk. King stands for kilo, and you can see there's 1,000 of them here. Henry stands for hecto, and there's 100 of them. D, deca, like a decade, stands for 10. And then the base unit, it would be the grams, the meters, or the liters. And then if we go the other side of the decimal, it would be a deci, which is 1/10, a centi, which is 1/100, or a milli, which is 1/1000. Now these numbers down here have no decimals. So if we're going to move the decimal, we have to remember that if there's no decimal point behind the last number, you can put one there without changing it. Pause this video right now for a second and go ahead and put the decimals where they belong on the numbers in this chart, and then come back and check your work. We can put the decimal and it does not change the number. Adding some extra zeros doesn't change the number. So 100.0 or 100.00 or 100.00, we can add as many zeros as we need to move the decimal around. So I put 2,450 point, and I added all these zeros, and it's still the same number. Same with this one. I can add as many zeros as I like, and it doesn't change the number. Now, in order to do the swoop method, I'm going to move myself over here out of the way so you guys can see better. We're going to find the starting point, and then we're going to find out where we're going. And then we swoop from the starting point to where we're going on the chart, and we move that decimal the same number of swoops in the same direction. So if Mr. Palmer said, convert kilos to the base unit, we would look up here on the chart, and we would find where we're starting. And I said to start with kilos. and I said to come over here to the base unit, which is grams. So we would swoop once, we would swoop twice, we would swoop 3 times. So we would move the decimal place over 1, 2, 3. Let's look at some practice. It says change. It says change 2,000 milligrams to grams. We're going to find our starting point, milli, which is over here, and we're going to find our ending point, which is grams, which is the base unit. Now, we're going to go 1, 2, 3 swoops to get to the base unit. So we're going to remember that we can add the decimal point here to the 2,000. Okay, and our answer, we're going to swoop the same way. We swoop once, we swoop twice, we swoop 3 times. So the answer here would be 2 grams. Now you can also put the decimal and say 2.0 because adding zeros doesn't change anything. Okay, on this next one, it said to go from 5 liters over to milliliters. Liters is a base unit. So I'm going to start here, and it says go over to milli. So I'm going to swoop once, I'm going to swoop twice, and I'm going to swoop a 3rd time. So up here, I have 5.0 liters. And I can add some zeros, so I can do my swooping. And I'm going to swoop. This is where the decimal is starting. I'm going to go 1, 2, 3. So I find my starting point, and I swoop the decimal the same number of places as I counted down here. So my answer would be 5,000 milliliters. Okay, now let's take a look at the next one. The next one says go from 16 centimeters. So I look down here, centi is right here, and it says go over to millimeters. So I'm going to start off at centi, and I'm going to swoop once to millis. But I don't see a decimal here. So I know I can add a decimal. So 16.0 is the same as 16. And I'm going to swoop in the same direction one place. And my answer would be 160 millimeters. And again, you don't see a decimal here with the 104 kilometers. I'm going to add one there because I know that 104 point, and I can put as many zeros here as I need. Okay. Now it says to go from kilometers, which is over here, kilos, and go to the base unit. I find my starting point. I'm going to swoop once. I'm going to swoop twice. I'm going to swoop 3 times. So up here, I'm going to do the same thing. I went 3 places this way, so I'm going to go 3 places this way. 1, 2, 3. So this would be the same as 104,000 meters. Now this one says to go from grams to kilometers, or kilograms. Again, I don't see a decimal, but I know I can put one there so that I can swoop it. Okay, so it says to go from grams to kilos. So grams is a base unit, so I'm going to start here, base unit. And it says to go over to kilo, and I'm going to find kilo right here. And then I'm going to swoop once, I'm going to swoop a second time, and I'm going to swoop a third time to get there. So up here, my decimal has to go over 1, 2, 3, and it's going to end up right there. So my answer is going to be 0.198 kilograms. Okay, I'm going to move me over here so we can do this last problem together. Okay, it says to go from 2,500 meters to kilometers. Okay, meters is the base unit. I want to go to kilometers. So again, it's the same thing. I'm going to go 1, 2, 3 this way. So remember, I can add a decimal. And then I want to swoop once, twice, and the third time. So my answer would be 2.5 kilometers. So again, by changing the prefixes, we went from up here, we went from milli to the base unit. We went from the base unit to milli, but the amount stays the same. 5 liters of water, for example, in this is the same as 5,000 milliliters of water. So we can go from working with large quantities to units that would be for very small quantities, just by moving the decimal around and changing the prefixes.